is Lizel, and for today's lesson we are going to focus more about variables. So what is a variable? It shows here that sometimes thought of as a mathematical cento, because you can use it as a placeholder when you want to talk about something. So don't be confused about this name that shows on the screen. Cento is only like a screen name to associate with an identified individual. So like Americans, they use it in the US to refer to a person whose identity is unknown or unconfirmed. So right here we also have the meaning of variable, which is the one that represents something that needs to be discovered or found. So it is the thing that we use to know what is missing. So another is we have two most common variables which we encounter always, which is the variables x and y. So but any letter you can think of can be used as a variable, so they can be uppercase or lowercase. So what is the advantage of variable? So it shows here that it allows you to give a temporary name to what you are seeking, so can perform concrete computations with it to help discover its possible values. So basically mean that variable is making an easier way for us to calculation. So it represents what need to be found, so to speak. For us to have a clear view for what a variable is, let's have an example. So let's say I'm working and I'm making $10 per hour, and aside from that I have tips each hour. So we could have this entire expression in a given hour. So we can realize that the number of tips there that could change dramatically from hour to hour. So 1 hour it might be lunch, a lot of tips, and the next hour no customers, the tips might be really low, so that changes. So the tips part right over here, we can consider that to be a variable that could change scenario to scenario. So for an instance, let's say we have tips I get is $30. Let's say I get 30. So using the expression, we have 10 from the expression plus the tips I get, which is $30. So we're going to have 10 plus 30, which is going to be equal to 40. So $40 what I get on that time. So right after that, let's say the restaurant slows down out of the lunch hour for whatever reason. The tips goes down to $5 for that hour. So using the expression again, we have 10 plus tips, which is now $5, and that will going to be equivalent to $15 now. So this entire expression change depending on the value of the variable tips is. So you won't see any word typically used in math as a variable. So instead, we tend to use easier to write symbols. So for this instance, we could have 10 plus t, which represents the tip we earned in an hour. So for example, we have a while ago, we have tips, which is $30. So that's why we have 10 plus 30, and that is equivalent to 40. And we also have the tips, which is equivalent to 5, and so 10 plus 5, that's why we have 15. And I want to be clear, we don't even have to use t. We can also use any other letter. So we could also use 10 plus x, where x is your tips for an hour, and it's not the first letter of tips, but it's okay, we can still use it. And also we can use a symbol, which is a star, that could represent the tips for an hour. But hopefully it gives you a general idea just what a variable is. So all it is a symbol All it is a symbol that represents different varying values. That's why we called it a variable.
So now I'm going to discuss on how you write a sentences using a variables.
1.
As you can see, there are some of examples on how you write a sentences using the variables. So here are the example. Example number 1. Are there numbers with the property that the sum of their squares equals the square of their sum? So the parameter in this statement are the numbers with the property that the sum of their squares equals the square of their sum. So we're gonna substitute it with the variables. So here are the solution. Are there numbers A and B? So we use the A and B as variables to substitute real numbers. With the property that A squared plus B squared is equal to, close and open parenthesis, A plus B squared. As I said, we can use any letters as a variables to substitute numbers. So we use other variables but with the same statement. So here are the example number 2. Given any real number, its square is non-negative. So the parameter in these sentences or statement is the real number, its square is non-negative. So you're gonna substitute it into variables. So here are the solution. Given any real number r, so we use a variable r as a substitute to real number. R squared is non-negative, or for any real number r squared is greater than equal 0. So we use a 0 to represent a non-negative number. So that's how you write a sentences using the variables. Thank you.
We have here another topic about some important kinds of mathematical statement. So what is mathematical statement? When we say mathematical statement, it is a sentence which is either true or false. So there are 3 kinds of mathematical statement. The first one is universal statement, second is conditional statement, and the lastly is the existential statement. So let's proceed to the universal statement. It says that a certain property is true for all elements in a given set. For example, all positive numbers are greater than 0. Another example is any number multiplied 0 is equal to greater than 0 multiplied to 1 is equal, so that same number. So that is a universal statement. Example of this is 1 times 1 is of course 1. 1 times 2 is of course 2. So 2 is greater than 0, exit for 0 times 1 is the result will be 0. So the next is conditional statement. Says that if one thing is true, then some other thing is also has to be true. If then. So let's say for example, if 378 is divided by 18, then 378 is divisible by 6. So of course, 378 is divisible by 6 and 18 is divisible by 6, since 18 is divisible by 6. So last is the existential statement. Says that there is at least one thing for which the property is true. So for example, there is prime number that is even. So when we say prime number, there are so many prime number. For example, is the number 2, number 3, 5, 7, 11, and so on. So, those are the numbers of prime numbers. It can only divided by 1 and itself. So, the only prime number is 2. So, the property of the prime number is only that is even. If only true for the number 2, so that is the example of an existential statement.
Universal conditional statements. A statement that is both universal and conditional. Here is an example. For all animals A, if A is a dog, then A is a mammal. One of the most important facts about universal conditional statement is that they can be written in a ways that make them appear to be purely universal or purely conditional. If A is a dog, then A is a mammal. Or, if an animal is a dog, then the animal is a mammal. The statement can also be expressed so as to make its universal nature explicit and its conditional nature implicit. For all dogs A is a mammal, or all dogs are mammal. Rewriting a universal conditional statement, fill in the blank to rewrite the following statement. This is the statement. For all real numbers x, if x is non-zero, then x squared is positive. A. If a real number is non-zero, then x squared is positive. Letter B. For all non-zero real numbers x squared is positive. Letter C. If x is a non-zero real number, then x squared is positive. Letter D. The square of any non-zero real numbers is positive. Letter E. All non-zero real numbers have positive square or squares that are positive.
Universal existential statements. A statement that is universal because its first part says that a certain property is true for all objects of a given type. And it is existential because its second part asserts the existence of something. Example, every real number has an additive inverse. The nature of additive inverse depends on the real numbers. Different real numbers have different additive inverse. Knowing that an additive inverse is a real number, you can rewrite this statement in several ways. Some are less formal, some are more formal. Example, all numbers have an additive inverses. Or, for real numbers R, there is an additive inverse for R. Or for real numbers R, there is a real number S such that S is an additive inverse. Rewriting the universal existential statements. Here are several ways writing the universal existential statements. The statement is, every path has a lead. The first way of rewriting the statement is, all paths have lead. The second is, all paths P, there is a lead for P. The third is, for all paths P, there is a lead L, such that L is a lead for P.
Existential universal statement. A statement that is existential because its first part asserts that a certain object exists, and it's universal because its second part says that the object satisfies a certain property for all things of a certain. The word assert means state a fact, and certain is specific but not explicitly or stated, which means if you're going to rewrite the word in a different way, it is already stated but just in a certain. For example, there is a positive integer that is less than or equal to every positive integer. It was being rewritten and some positive integer is less than or equal to every positive integer. Or, there is a positive integer m that is less than or equal to every positive integer. Or there is a positive integer m such that every positive is greater than or equal m. Or there's a positive integer m with a property that for all positive integer n, m less than or equal to n. Here's another example of rewriting an existential universal statement. We're going to fill in the blank to rewrite the following statement in 3 different ways. The given statement is, there is a person in my class who is at least as old as every person in my class. Letter A, some blank is at least as old as blank. Letter B, there is a person P in my class such that P is blank. Letter C, there is a person P in my class with the property that for every person Q in my class, P is blank. So here is the solution in the complete statement of the given statement. There is a person in my class who is at least as old as every person in my class. Letter A, some person in my class is at least as old as every person in my class. Letter B, there is a person P in my class such that P is at least as old as every person in my class. Letter C, there is a person P in my class with the property that for every person Q in my class, P is at least as old as Q. P is the variable that represents the person. Q is the variable that represents the statement for every person in my class.
In this lesson, we will focus on mathematical language and symbols. This is a language of set. What is language of set? Language of set, it is defined a group of objects called elements. So we have here the notations and meaning. First is set. So set, it is defined the collection of distinct objects represented by listing its element between braces. Example, the set of cell phones. To represent the set, we need to use a capital letter and enclose natin doon yung member ng set using bracket. So, yung i-enclose natin doon is yung cell phones by using 2 bracket. Second is element. Element, this is the object inside the sets. So, yun na nga, yung elements doon is yung cell phones. Third is not an element. Next is X, element S. So, if S is a set, the notation of X, element S, it means X is an element of S. Then, X, not element S, this means X is not an element of S. So, these notations can specified by 2 sets. These are the set roster notation and then set builder notation.
Set roster notification, it is a set of all elements are listed, each element separated by comma and brackets. And it is specified by writing all of elements between braces. For example, open and close braces 1, 2, 3 denotes the set whose elements are 1, 2, and 3. A variation of notation is sometimes used to describe a very large set, as when we write open and close braces 1, 2, 3 to 100 refer to the set of all integers from 1 to 100. So, pag sinabi nating variation of notation, it's describe a very large of set which is 1 from 1 to 100. And a similar notation that can also describe an infinite set
as when we write open and close braces 1, 2, 3, and so forth to refer the set of all positive integers. So pag sinabi naman natin similar notation, it can describe an infinite set of all positive integers. The symbol of this is called ellipsis, or when we read it as and so forth. Here is the example of set roster notification. How many elements are in set 1 and 1 closed by the braces? The answer is, the set 1 and 1 closed by the braces has 2 elements, 1, and the set whose only element is 1. Letter B example is open and close braces 0 is equal to 0. Therefore, they are not equal because the 0 with the open and close braces are represented as the set of 1 element.
This describe or define the elements of the sets instead of listing the elements. I am Kayla Marie S. Gaves and I'm going to discuss about the set builder notifications or notations. Set builder notifications is the set of all elements that can describe by specify the property which determine the elements of the set uniquely. Let S denote a set and let P of X be a property. The elements of S may or may not satisfy. We may define a set to be the set of all X in S such that P of X is true. To read these set notations, the bracket called set and the E is the elements. The bar in the middle can be read as such that, and the rest, the general property of all numbers in the set. Like, the set of all X is an element of S such that P of X. For example, given that R denotes the set of all real numbers and describe the following. The answer is, the set of all X is not an element of R such that X less than -2 and greater than 5. Another examples, set of 1, 2, 3, 4, 5, 6, 7, 8, and 9 is the list of the elements. The set of all X such that X is the counting numbers less than 10. The next is the subset.
Hi, we are going to talk about subset. So, the definition of subset is a basic relation between set is that of a subset. A set A is called the subset of set B if every element of set A is also a member of set B. Suppose if we have a set A whose elements are 1, 2, 3, 6, and 9, and if we have a set B whose elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, this is a set of first 10 natural numbers, right? Then, if you see properly all the elements of set A are there in set B. These first 3 elements are the first 3 elements of set B. Then we have a 6, 6 is over here. Then we have a 9, and 9 is over here. Then, the set A is called the subset of set B, right? A is a proper subset of set B because few more elements which are there in set B and not there in set A, right? So that is why this is A is called the proper subset of set B. And then, if we follow this definition, the set A is called a subset of set B if every element of set A is also a member of set B, right? So, according to this definition, every set A is actually a subset of itself, right? And this is actually written as is a subset or equal to itself, right? Similarly to set B is also a subset of the set B itself, and both of them are equal. Why are they equal? Their cardinal numbers is same and they have exactly same elements.
Example,
let A equals to Z, B is equals to, open parenthesis, and those not belong to Z, 10 less than or equals to 100, close parenthesis, and C is equals to, open parenthesis, 100, 200, 300, and 400, 500. Huwag natin kakalimutan ang open and close parenthesis. I-evaluate natin ang truth and falsity of each of the following statements. A. B subset of A. Answer. False. 0 is not positive integer. Thus, 0 is not in A and so B subset of A. B. C is a proper subset of A. Answer is true. Each element in C is a positive integer and hence is in A. Pero meron ditong elements sa A na wala sa C. So, for instance, 1 is A and not in C. C. C and B have one element in common. Answer, for example, yung 100 ay nasa both C and B, so yung answer is true. D. C is subset of B. Answer is false. For example, yung 200 ay nasa C, pero wala sa B, so the answer is false. Next is E. C subset of C. Answer is true. Kasi yung element sa C ay nasa C. In general, the definition of subset implies that all sets are subsets of themselves.
Let us know what is Cartesian product. Cartesian product. The Cartesian product is named after René Descartes' formulation of analytic geometry, gave rise to the concept, which is further generalized in terms of direct product. Cartesian products symbolize A cross B, the set of ordered pairs of the form column A, B column that can be formed from the element in each set. The number of order is always equal to the product of the number of elements in each set. Like A cross B is equals to column A, B, column A elemental to A and B elemental to B. So here's the given example here. In set A, it was column dog, cat, fish, column. And set B as column 3, 4, column. And now, let's find out. In letter A, it was being denoted into A cross B is equals to dog, 3, dog, 4, cat, 3, cat, 4, fish, 3, and fish, 4. Letter B, it was B cross A is equals to 3, dog, 3, cat, 3, fish, 4, dog, 4, cat, and 4, fish. While in letter C, it was B cross B equals 3, 3, 3, 4, 4, 3, and 4, 4. If you're going to look carefully in letter A and letter B, it was a two-ordered pairs of sets, and letter C is the equal number of two sets.
We are going to discuss the language of relations and functions. When you say relation is a rule that relates values for a set of values, call that as a domain, to a second set of values, and we call that as a range. The elements of the domain can be imagined as input to a machine that applies a rule to this input to generate one or more outputs. A relation is also a set of ordered pair, x and y. For example, 1, 2, 2, 4, 3, 6, 4, 8, and 5 and 10. So, yung 1, 2, 3, 4, and 5 is called as a domain. The 2, 4, 6, 8, and 10 is called as a range. A relation as a subset. For example, Let's set A equal 1 and 2 and set B is equal to 1, 2, 3 and define as relation R from A to B as follows. Given the statement that your X and Y is an element of the product of set A and B, and so X and Y element of relation R, it means that the statement X minus Y over 2 is an integers. And we're going to answer the following question. First, state explicitly which ordered pair are in A times B and which are in relation R. Second, is 1 related to 3? Is 2 related to 3? Is 2 related to 2? Last, what are the domain and range of relation R? Let's answer and explain the question. So, let's answer the number 1 question. First, we need to get the product of set A and B to get the product. So, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3. All of this set of ordered pair. Substitute of all of the given statement. When we say integer, includes that negative number 0 and positive numbers. That output of 1 and 1 is 0, so that 1 and 1 is an element of relation R. 1 and 2 is not element of relation R because the output is negative 1/2 ang makukuha natin. 1 and 3 is an element of relation R because if substitutes this equals negative 1 because negative 1 is an integer. 2 and 1 is not element of relation R because if substitutes to the given statement equals 1/2 and 1/2 is not an integer. Another 2 and 2 is an element of relation R because equals to 0 because 0 is an integer. 2 and 3 is not element of relation R because equals negative 1/2. It's not an integer. So, therefore, the element of relation R, that is 1, 1, 1, 3, and 2, 2. Number 2 question. Is 1 related to 3? Is 2 related to 3? Is 2 related to 2? So, we will base the answer on the answer to number 1. Is 1 is related to 3? Yes, because 1 and 3 is an element of relation R. And then 2 is related to 3, the answer is no, because 2 and 3 is not element of relation R. Because the output is negative 1/2. Next, 2 is related to 2. The answer is yes, because 2 is an element of relation R. Question number 3. What are the domain and range of R? So, in the given problem, set A is our X values, and set B is our Y values. Therefore, the domain of relation R is 1 and 2, and the range is 1, 2, and 3.
The circle relation. Define a relation C from R to R as follows. So, for any X and Y is an element of R cross R. So, X and Y is an element of C, means that X squared plus Y squared is equal to 1. So, X and Y, that is the ordered pair. An element of C, the C means a circle. And the formula is X squared plus Y squared is equal to 1. For the letter A, it says here is 1, 0 an element of C? Is 0 and 0 an element of C? Is negative 1/2 and square root of 3 over 2 an element of C? Is negative 2 a circle of 0? Is 0 circle of negative 1? Is 1 circle 1? Letter B. What are the domain and codomain of C? And letter C. Draw a graph for C by plotting the points of C in the Cartesian plane. Letter A. Answer for 1 and 0 is an element of C. Answer for that is yes, because 1 squared plus 0 squared is equal to 1. So 0 and 0 is an element of C. Answer for that is no, because 0 squared plus 0 squared is equal to 0. So that is not 1. Next is negative 1/2 and square root of 3 over 2 is an element of C, because negative 1/2 squared plus square root of 3 over 2 squared is equal to 1/4 plus 3/2 is equal to 1. So that is a yes. Next is negative 2 is a circle of 0. Answer for that is no, because negative 2 squared plus 0 squared is equal to 4. So that is not 1. And next is 0 is a circle of negative 1. Answer for that is yes, because 0 squared plus negative 1 squared is equal to 1. So negative plus negative is equal to positive. So next is 1 is a circle of 1. Answer for that is no, because 1 squared plus 1 squared is equal to 2, and that is not 1. So the next is the domain and codomain of C are both R, the set of all real numbers. And for the last, letter C shows the picture of the graph for C in the Cartesian plane.
So now, let's talk about function. A function is a relation where each element in the domain is related to only one value, in the range by some rule. A function is a set of ordered pairs, x and y, such that no two ordered pairs have the same x value but different y values. The elements of the domain can be imagined as input a machine that applies a rule so that each input corresponds to only one output. Function can be represented in different ways. First, a table of values. Second, ordered pair. Third, graph. Fourth, an equation. And last, mapping diagram. Now, let's determine in mapping diagram if it's function. As you can see, the figure shown in the first picture is a function because the x value is not repeated and it's also called one-to-one function. The second one, same as the first one, it is a function and it's also called many-to-one function. The third one is not a function because the x value is being repeated. Now, let's answer which of the following represent a function. Number 1 is a function. Number 2, function. Number 3, not function, because if we use a graph, it will form a circle and it will have 2 points of intersection. Number 4 is a function. Number 5 is also a function.
The vertical line test. A graph represents it and only if each vertical line intersects the graph at most once. For example, in this first graph, when we draw a vertical line on any part of the graph and only one point is passed, this is a function. The second graph is also a function. In this third graph, this is not a function. Why? Because 2 points of the graph are passed by the vertical line test. Only 1 point of the graph must be passed. So therefore, this is not a function. Evaluating a function. Evaluate 9 of x equals x squared minus 2x plus 2. When your x is equals to, we are going to change all of x with 2. Q of 2 is equals x squared minus 2x plus 2 is equals to 2 squared minus 2 times 2 plus 2 equals 4 minus 4 plus 2.
the q of 2 is equals to. Reminders, always change the x with a number.
Functions and relation on set of real numbers. A. The circle relation C was defined as follows. For all x and y element, relation R, the set of R and x and y element C means that x squared plus y squared equals 1. Is C a function if its find C is 0 and C is 1? B. Define a relation from relation R to R as follows. For all x and y element, relation R, the set of R, x and y element, L means that y equal x minus 1. Is L a function if its find L is 0 and L is 1? This is the solution. A. The graph of C shown below indicates that C does not satisfy either function property. To see why C does not satisfy proper 1, observe that there are many real number x such that x and y not an element C for any y. This is the graph of C. X squared plus y squared equals 1. The bracket of 1/2 and square root of 3 over 2. X equal 2. And 1/2 square root of 3 over 2. X equals 1/2. For instance, when x equals 2, there is no real number y, so that x squared plus y squared equals 2 squared plus y squared equals 4 plus y squared equals 1. Because if there were, then it would have to be true that y squared equals negative 3. To see why C does not satisfy proper 2, note that for some value of x, they are distinct value of y, so that x and y element of C. Let's go about the function machine. This is another useful way to think of a function as a machine. And suppose f is a function from x to y and an x of x is given. Imagine f to be a machine that processes x in a certain way to produce the output f of x. It is the best represented as a function machine. For example, input for x value, if naglagay ka dyan sa machine, then pumasok siya sa loob at nandoon si function at doon mag-process ang input using the function. At now, the process ang machine kaya lumabas si output which is your y, and ibig sabihin ang output mo ay depende sa kung ano ang input na pinasok mo. So ito po ating input, that is aware domain, which is set of all inputs that is our x, and at dadaan siya sa ating function role at lalabas na yung range, which is the set of all output o yung y natin.
Functions defined by formulas. The squaring functions f from R to R, which is the R in the symbol is the set of the real number, is defined by formulas f open parenthesis times close parenthesis equal x squared for all real number x. This idea can be represented by writing f open parenthesis blank close parenthesis is equal to blank plus 1. In other words, f send f colon x to x squared. The successor functions g from z to z, the z symbol is the set of the integers, is defined by the formula j open parenthesis n close parenthesis equal n plus 1. N is the set of the natural number. Thus, no matter what integers is substitute for n, the output of g will be the number plus 1g open parenthesis blank close parenthesis is equal to blank plus 1. Constant functions is the functions of h from q to z, which is the set of the rational number to the set of the integers, defined by formula h open parenthesis r close parenthesis equal to. For all rational numbers r, in other words, no matter what input, the output is always 2. H open parenthesis blank close parenthesis equal to, or h colon r 2 2. Let's proceed to the functions f, g, and h are represented by the function machine. In this figure, we identify the three formulas of functions, which is the domain. The domain is simplified the set of objects that fit into the input funnel and can be perceived by the functions machine. The codomain. You could think of the codomain as the set of the object that could theoretically fit out the acute. The range. The range is the set of objects that will come out the code if you put all the elements of the domain into the funnel. A function is entity in its own right. It can be as a certain relationship between sets or as an input or output machines that operates according to a certain role. This is the reason why a function is generally denoted by a single symbol or string of a symbol such as f, g, or log, or sin. A relation is a subset of Cartesian product, and a function is a special kind of relations. F equal brace, open parenthesis, x, y, close parenthesis, elements of A times BLY equal F, open parenthesis, x, close parenthesis, braces. And G braces, open parenthesis, x, close parenthesis, elements of A times BLY equal G, open parenthesis, x, close parenthesis, braces. It is follows that F equals to G, writing F equal G if and only if F open parenthesis x close parenthesis equal G open parenthesis x close parenthesis for all x and A. Equality of functions. Define F colon R to R, which is F colon the set of the real number to the set of the real number, and G colon R to R by the following formulas. F open parenthesis x close parenthesis equal 1 times 1 for all x elements of R. G open parenthesis x close parenthesis equal square root of x squared for all x elements of R. Thus F equal J. Let's see the solution. What do you think? It is yes, because the absolute value of any real number equals the square roots of its square. 1 times 1 equals square root of x squared for all x elements of R. Hence, F equal J. Two functions are equal if they are the same domain and codomain, and their values are the same for all elements of the domain.